Hi again. Wow, I'm on a roll, but I have 3 piles of mulch in my driveway, in this driveway now. Seven Heaven has lots of mulch, lots of black gold, and so I might be disappearing into a pile of mulch for days or weeks on end until I get it done. This arborist mulch really is like black gold in a way. It's hard to say now. I already had a load on order, and then I got two loads from the neighborhood when trees went down, and then the third one showed up yesterday, and I just couldn't turn them away because it really does feel like someone dumped a pile of gold on your lawn, especially seeing the fruit trees back here, how happy they are. And so I got a lot of work ahead of me. If anyone lives in the Tampa area and wants to come help shovel mulch into a wheelbarrow, I would love for your help. But for now, been enjoying this James Clerk Maxwell treatise on Electricity and Magnetism. This is the first. I started printing out the first book. He has 2. But James Clerk Maxwell, when he came out with this, it was a big deal in the, let's see, I want to say 1800s. I don't have all the details, but I just want to go ahead and read some of this and then talk a little bit more about Tom Bearden's work that I have been diving into recently and how fun that is. But this is quite fun. And actually, before I start reading this, just to talk a little bit more, Maxwell had introduced these differential equations with these books that are still in use today, and they just, I feel like he just went through and described mathematically a lot of things that happen on the quantum level, and a whole bunch of equations and whatnot. I've yet to start diving into the equations, but learning what each variable stands for, velocity, acceleration, it's basically, they've got their own code, they've got their own language, and when we just take the time, it's kind of like when I learned Greek. First I had to learn the alphabet, I had to learn all the symbols and the sounds that they made, and this is the same thing with physics. It's just a matter of taking the time to learn what the symbols mean, and then at that point it's just a matter, it's usually just multiplication and exponents and whatnot to do the actual calculations. So I really am convinced that none of this is meant to be beyond our ability to comprehend if we put the effort in. So Maxwell came out with those equations, and I do know that there was someone named Oliver Heaviside who was quite gifted and made a lot of important contributions. And he took Maxwell's equations and he was trying to make them easier for students. And what he did was he removed, from these equations, he removed the spin, what's known as the quaternion, the element of spin. So if you're working with the differential equations that were modified by Heaviside, they're basically like static, fixed locations, and it's kind of trying to work with this reality as if it was fixed, but it's not. So I'm not sure if that's helpful. Personally, I feel like I would just want to learn the equation with spin and from the get-go, especially knowing this, because Tom Bearden, who I'll talk about after I read a little bit, he was adamant about this, that this is something that people need to be aware of and not a good thing. And anyway, so it's pretty well known, but being new to this field in general, I'm learning. So let's just go for it. I'm just going to read the preface for you all, because I really enjoy this. The fact that certain bodies, after being rubbed, appear to attract other bodies was known to the ancients. In modern times, a great variety of other phenomena have been observed and have been found to be related to these phenomena of attraction. They've been classed under the name of electric phenomena, amber, electron, having been the substance in which they were first described. So amber is, so electron is the Greek word for amber. And so because they were finding electrical phenomena with these pieces of amber, which is fossilized pine resin, so they named electricity after amber, which is electron. Other bodies, particularly the lodestone and pieces of iron and steel which have been subjected to certain processes, have also been long known to exhibit phenomena of action at a distance. That's what Einstein called spooky action at a distance. But with Dan Winter's work in the Planck fire formula, we have a much better comprehension of why it's happening at a distance and what's going on. But so these phenomena, with others related to them, were found to differ from the electric phenomena and have been classed under the name of magnetic phenomena. The lodestone magnes being found in the Thessalian Magnesia. So again, electricity and magnetism were named after the substances, the Greek names of the substances where they were observing these phenomena in ancient times. These two classes of phenomena have since been found to be related to each other, and the relations between the various phenomena of both classes, so far as they are known, constitute the science of electromagnetism. In the following treatise, I propose to describe the most important of these phenomena, to show how they may be subjected to measurement, and to trace the mathematical connections of the quantities measured. Having thus obtained the data for a mathematical theory of electromagnetism, and having shown how this theory may be applied to the calculation of phenomena, I shall endeavor to place in as clear a light as I can the relations between the mathematical form of this theory and that of the fundamental science of dynamics, in order that we may be in some degree prepared to determine the kind of dynamical phenomena among which we are to look for illustrations or explanations of the electromagnetic phenomena. In describing the phenomena, I shall select those which most clearly illustrate the fundamental ideas of the theory, omitting others, or reserving them till the reader is more advanced. The most important aspect of any phenomena from a mathematical point of view is that of a measurable quantity. I shall therefore consider electrical phenomena chiefly with a view to their measurement and defining the standards on which they depend. In the application of mathematics to the calculation of electrical quantities, I shall endeavor in the first place to deduce the most general conclusions from the data at our disposal, and in the next place to apply the results to the simplest cases that can be chosen. I shall avoid as much as I can those questions which, though they have elicited the skill of mathematicians, have not enlarged our knowledge of science. The internal relations of the different branches of the science which we have to study are more numerous and complex than those of any other science hitherto developed. Its external relations, on the one hand to dynamics, and on the other to heat, light, chemical action, and the constitution of bodies, seem to indicate the special importance of electrical science as an aid to the interpretation of nature. It appears to me, therefore, that the study of electromagnetism in all its extent has now become of the first importance as a means of promoting the progress of science. Give me chills. The mathematical laws of the different classes of phenomena have been to a great extent satisfactorily made out. The connections between the different classes of phenomena have also been investigated, and the probability of the rigorous exactness of the experimental laws has been greatly strengthened by a more extended knowledge of their relations to each other. Finally, some progress has been made in the reduction of electromagnetism to a dynamical science by showing that no electromagnetic phenomenon is contradictory to the supposition that it depends on purely dynamical action. What has been hitherto done, however, has by no means exhausted the field of electrical research. It has rather opened up that field by pointing out subjects of inquiry and furnishing us with means of investigation. It is hardly necessary to enlarge upon the beneficial results of magnetic research on navigation and the importance of a knowledge in the true direction of the compass and of the effect of the iron in a ship. But the labors of those who have endeavored to render navigation more secure by means of magnetic observations have at the same time greatly advanced the progress of pure science. So they're just trying to help out people navigate, people that had big ships, and just trying to help them out. They were advancing science. Pretty cool. Gauss, as a member of the German Magnetic Union, brought his powerful intellect to bear on the theory of magnetism and on the methods of observing it. And he not only added greatly to our knowledge of the theory of attractions, but reconstructed the whole of magnetic science as regards the instruments used, the methods of observation, and the calculation of the results, so that his memoirs on terrestrial magnetism may be taken as models of physical research by all those who are engaged in the measurement of any of the forces of nature. The important applications of electromagnetism to telegraphy, again, telegraphs back in the day, 1800s, have also reacted on pure science by giving a commercial value to accurate electrical measurements and by affording to electricians the use of apparatus on a scale which greatly transcends that of any ordinary laboratory. The consequences of this demand for electrical knowledge and of these experimental opportunities for acquiring it have been already very great, both in stimulating the energies of advanced electricians and in diffusing among practical men a degree of accurate knowledge which is likely to conduce to the general scientific progress of the whole engineering profession. So again, navigation of ships, enhancing the accuracy of telegraphs, or telegrams, I guess, telegraphy. So commercial applications motivating scientists to solve problems and coming up with new science as a result. This is great. This is what we're doing right now. And I guess all the time as humans. So there are several treatises in which electrical and magnetic phenomena are described in a popular way. These, however, are not what is wanted by those who have been brought face to face with quantities to be measured and whose minds do not rest satisfied with lecture room experiments. There is also considerable mass of mathematical memoirs, which are of great importance in electrical science, but they lie concealed in the bulky transactions of learned societies. They do not form a connected system. They are of very unequal merit, and they are for the most part beyond the comprehension of any but professed mathematicians. I have therefore thought that a treatise would be useful which should have for its principal object to take up the whole subject in a methodical manner, and which should also indicate how each part of the subject is brought within the reach of methods of verification by actual measurement. The general complexion of the treatise differs considerably from that of several excellent electrical works, published, most of them in Germany, and it may appear that scant justice is done to the speculations of several eminent electricians and mathematicians. One reason of this is that before I began the study of electricity, I resolved to read no mathematics on the subject till I had first read through Faraday's experimental researches on electricity. I was aware that there was supposed to be a difference between Faraday's way of conceiving phenomena and that of mathematicians, so that neither he nor they were satisfied with each other's language. I just expressed this last night in the video I did, that, you know, sometimes scientists are speaking their own language and we just have to learn how to communicate with each other. I had also the conviction that this discrepancy did not arise from either party being wrong. I was first convinced of this by Sir William Thomson, to whose advice and assistance, as well as to his published papers, I owe most of what I have learned on the subject. As I proceeded with the study of Faraday, I perceived that his method of conceiving the phenomena was also a mathematical one, though not exhibited in the conventional form of mathematical forms, of mathematical symbols. I also found that these methods were capable of being expressed in the ordinary mathematical forms, and thus compared with those of the professed mathematicians. So he was able to bridge Faraday's work with these mathematicians. For instance, Faraday, in his mind's eye, saw lines of force traversing all space, where the mathematicians saw centers of force attracting at a distance. Faraday saw a medium, where they saw nothing but distance. Faraday sought the seat of the phenomena in real actions going on in the medium. They were satisfied that they had found it in a power of action at a distance impressed on the electrical fields. When I had translated what I considered to be Faraday's ideas into a mathematical form, I found that in general, the results of the two methods coincided, so that the same phenomena were accounted for, and the same laws of action deduced by both methods, but that Faraday's methods resembled those in which we begin with the whole and arrive at the parts by analysis, while the ordinary mathematical methods were founded on the principle of beginning with the parts and building up the whole by synthesis. I also found that several of the most fertile methods of research discovered by the mathematicians could be expressed much better in terms of ideas derived from Faraday than in their original form. The whole theory, for instance, of the potential, considered as a quantity which satisfies a certain parallel differential equation, a certain partial differential equation, belongs essentially to the method which I have called that of Faraday. According to the other method, the potential, if it is to be considered at all, must be regarded as the result of a summation of the electrified particles divided each by its distance from a given point. Hence, many of the mathematical discoveries of Laplace, Poisson, Green, and Gauss find their proper place in this treatise and their appropriate expression in terms of conceptions mainly derived from Faraday. Great progress has been made in electrical science, chiefly in Germany, by cultivators of the theory of action at a distance. The valuable electrical measurements of W. Weber are interpreted by him according to this theory, and the electromagnetic speculation which was originated by Gauss and carried on by Weber, Riemann, J. and C. Neumann, Lorentz, etc., is founded on the theory of action at a distance, but depending either directly on the relative velocity of the particles or on the gradual propagation of something, whether potential or force, from the one particle to the other. The great success which these eminent men have attained in the application of mathematics to electrical phenomena gives, as is natural, additional weight to their theoretical speculations, so that those who, as students of electricity, turn to them as the greatest authorities in mathematical electricity would probably imbibe, along with their mathematical methods, their physical hypotheses. These physical hypotheses, however, are entirely alien from the way of looking at things which I adopt. And one object which I have in view is that some of those who wish to study electricity may, by reading this treatise, come to see that there is another way of treating this subject which is no less fitting to explain the phenomena, and which, though in some parts it may appear less definite, corresponds, as I think, more faithfully with our actual knowledge, both in what it affirms and what it leaves undecided. In a philosophical point of view, moreover, it is exceedingly important that two methods should be compared, both of which have succeeded in explaining the principal electromagnetic phenomena, and both of which have attempted to explain the propagation of light as an electromagnetic phenomena, and have actually calculated its velocity, while at the same time the fundamental conceptions of what actually takes place, as well as most of the secondary conceptions of the quantities concerned, are radically different. I have therefore taken the part of an advocate rather than that of a judge, and have rather exemplified one method than attempted to give an impartial description of both. I have no doubt that the method which I have called the German one will also find its supporters, and will be expounded with a skill worthy of its ingenuity. I have not attempted an exhaustive account of electrical phenomena, experiments, and apparatus. The student who desires to read all that is known on these subjects will find great assistance from the Traité d'Electricité of Professor A. de la Rive, and from several German treatises, as well as Wiedemann's Galvanismus, Rice's Reibungselektricität, Beer's Einleitung in die Elektrostatik, etc. I have confined myself almost entirely to the mathematical treatment of the subject, but I would recommend the student, after he has learned experimentally if possible what are the phenomena to be observed, to read carefully Faraday's experimental researches in electricity. He will find there a strictly contemporary historical account of some of the greatest electrical discoveries and investigations, carried on in an order and succession which could hardly have been improved if the results had been known from the first, and expressed in the language of a man who devoted much of his attention to the methods of accurately describing scientific operations and their results. It is of great advantage to the student of any subject to read the original memoirs on that subject, for science is always most completely assimilated when it is in the nascent state. And in the case of Faraday's researches, this is comparatively easy, as they are published in a separate form and may be read consecutively. If by anything I have here written I may assist any student in understanding Faraday's modes of thought and expression, I shall regard it as the accomplishment of one of my principal aims, to communicate to others the same delight which I have found myself in reading Faraday's researches. The description of the phenomena and the elementary parts of the theory of each subject will be found in the earlier chapters of each of the four parts into which this treatise is divided. The student will find in these chapters enough to give him an elementary acquaintance with the whole science. The remaining chapters of each part are occupied with the higher parts of the theory, the processes of numerical calculation, and the instruments and methods of experimental research, the relations between electromagnetic phenomena and those of radiation, the theory of molecular electric currents, and the results of speculation on the nature of action at a distance are treated of in the last four chapters of the second volume. Okay, so that's it. That's the preface, and that was enjoyable. And I love that he's pointing us to Faraday's work. He's like, okay, well, I did all this, but really, if I'm wanting to help you, go read Faraday's work. And so I really love some of these guys. It's almost like I'm tapping into their consciousness of who they were when they were here, and it's like sometimes you can just feel the excitement, and you can feel it as if it's happening right now, because really all time is now. The past and the future really shift all the time. When we change our view of a past event and we have compassion for someone and we realize, oh, that wasn't that bad and it happened because of such and such and such. Well, our view of the past changes based on where we are now. So it's constantly shifting, the past and the future, past, present, future, it's all now. I did want to just tell you a little bit more about, briefly about what I was hearing from Tom Bearden yesterday, or a couple days ago, and then that'll be it for today. But he was discussing the process of how we would take something like water and generate fuel with it, and this is quite a hot topic these days. Not sure when he had done this video. He's passed, so it's definitely been a few years. But he talks about this vacuum, which is, he says a synonym is space-time, and then another synonym he uses is virtual particle flux. Virtual particle flux. So looking at this base layer of reality, where you could say everything is one, it's all just energy swirling around, there is no separation. So if we're going to go to this, really fundamental layer, and we want to work with that layer, then we talk about this, to use this term, virtual particle flux. So virtual. I keep talking about holographic universe theory. I keep talking about many worlds interpretation, how this is essentially like a video game, and when we recognize that and we say, okay, this is my avatar, I get to be the player in the way that I want, and I can even adjust the game board if I want. We're working on that deep layer, and instead of just using our minds to say, oh, I want to go do this and this, saying, how can I work with that fundamental layer and shift that? And then this reality around me is going to shift as a result. And so basically how he just describes it is that all this reality around us is constantly being created in every moment. It's not just static in there. No, it needs to continuously be generated, just like a computer game would continuously render for the player. It's not just static, it has to always be rendering. Same thing here. The water particles are existing. The oxygen and hydrogen are bonded because of there was enough energy down here in this virtual particle, quantum foam, quantum soup. There was enough energy to generate that complexity at the top, but it has to continually be generated. There has to be enough energy on this, there has to be the right conditions on this virtual particle flux layer for the physical matter to stay in existence. It has to continually stay in existence all the time. To us, it just looks like, oh, this ruler is here and it's fixed, but this ruler is constantly being generated moment to moment. So what he talks about is this scientist named Kanzias, whether he knew what he was doing or not, Bearden seemed to think that he didn't even understand why he was getting the result he did, but he came out saying that he had found what seemed to be a cure for cancer, and while looking for the cure for cancer, he had stumbled upon the ability to use RF pulses, radio frequency pulses, in the water to basically decouple the hydrogen and oxygen atoms, which basically creates fuel. But by what he was doing with those RF pulses is he was disturbing or modifying or interacting with that virtual particle flux layer, and by introducing these RF pulses, it basically was like introducing negative energy to the system, to where those oxygen and hydrogen atoms in the form of water no longer had the right conditions to form the water. So the water, as Bearden puts it, unhappened. You unhappen the bonds of the water. And this stuff is so exciting to me when I hear it, but when you hear him talking in the video, he says how literally the scientists and physicists were so scared about this, and that, when these, I guess, groups of men have found, well, it's women too, but it's, it has been a lot of a certain type of person, it was scary to them. They're like, whoa, we can change the game board of this virtual reality? oh boy, we better put that back in the box, put the lid back on. We know that never really happens, and you know, humans are craving discovery, craving knowledge, so we play these little games of hiding things from ourselves, but ultimately the truth always gets out. So anyway, that I just sort of wanted to go over this virtual particle flux layer, and how all this reality around us is constantly being generated, constantly. And that's why, you know, we can dramatically shift this layer if we learn, you know, for the better, consciously, intentionally, if we develop, when this is happening now, by continuing to develop and advance this science of working with that fundamental layer and introducing energy in a specific form, we can dramatically modify the world around us in ways that I'm sure are beyond our imagination at this moment, really. Taking a piece of land that had been destroyed by chemicals or pollution or whatnot, being able to introduce the right amount of frequencies to decouple those bonds and bring those molecules back down to fundamental particle states that are not harmful to the earth. I mean, the implications are massive, right? Of course, there's everything that's good for humans there's also a weaponized version of it. So, of course, this has a lot of implications, and this is nothing new, but it's, you know, we're now, as everyday humans with the internet, we're now capable of tapping into this incredible information. Even though it's not new, it might be new to us. We can now find all these gems of describing the world around us. And so I suppose that's it for today. And who knows, I do really enjoy making these videos. It feels great, and I get a lot out of it. And just reading this preface again, I just anyway, I'm just rambling here. So much love to you all. Thanks again for joining me across time and space and joining the others. And I'm sure there's more stuff to come soon, but until then, we'll see you all next time. Take care.